everyone. I'm Riccardo Magliocchetti. I work as a senior engineer on observability at Elastic, where I maintain our Elastic distribution of OpenTelemetry Python. And I'm also like a maintainer for the upstream OpenTelemetry Python project, one of the maintainers, of course. So in this talk, I want to show you like how OpenTelemetry Python works under the hood. And we see how we're able to automatically recognize and install instrumentation libraries using OpenTelemetry-bootstrap. Then we'll discover how OpenTelemetry instrument is able to leverage the Python same module to enable automatic instrumentation of your applications. And then we'll see how entry points are used to discover components in different packages. And later, we'll see how instrumentations libraries are able to patch third-party code. So the plan is to give you an overview on how the OpenTelemetry Python code, but also to so hopefully you may also learn something new that can be applied to your code bases too. So I'll start by giving people that are new to this space like a bit more context on observability and OpenTelemetry. And how many of you already knows OpenTelemetry? Please raise your hands. Okay. I didn't expect that many hands. Nice. It's more like half of the room. And then how many of you are already using OpenTelemetry in production? Oh, a ton of people. Thank you. Okay. While we're at it. Any of you are working as a SRE, platform engineer, stuff like that? Okay. Any developers, Python developers? Okay, most of the people. Okay, thank you. Okay, let's start. So what is observability? Observability is the ability to understand a system, the internal state of a system, by examining its outputs. This means being able to understand a software system by looking at the telemetry data it exports. The telemetry data is about the program's execution, internal states, and the communication between the components of our system. So OpenTelemetry is an open source and vendor-neutral observability framework. It provides both specification and implementation in different languages, and Python included, in order to create and manage telemetry data. This telemetry data may be like traces, for tracing execution of software paths, so calls into and from your application. Think of database calls, HTTP calls, RPC calls, function calls, and so on and so forth. And as an example of tracing, it may look something like this. Like in this picture, we are tracing, and we see traces of free services. So we're seeing what these services are doing. And also the dependencies between them. I don't know if everyone can see the free services very displayed in different colors. So we have one service is in green, I think, calling one in blue, calling back to the one in green, and at the end, this one is calling again another services. So the idea, also the ability of being able to follow the flow or request through different services is also called distributed tracing, which is something you may already know. And another kind of telemetry data we have in OpenTelemetry are metrics. Metrics are used to capture some measurement at runtime. For example, think of memory usage, CPU usage, but also like something more like business-oriented, like number of requests, or also the time spent serving this request. And as a metric example, this is a very simple one. This is a chart that is displaying just some CPU usage of an host, and also of a pod inside the Kubernetes cluster. So I think also this is nothing like tracing memory CPU usage, probably nothing new to you. And then we have logs. Logs are some structured or unstructured text with a timestamp. And I hope this definition works for you too. And as an example, here we have an interface where we are like running a service, a demo, but it's called the OpenTelemetry demo, where a bunch of services in different languages are running. And in this case, we are just filtering the logs exported by a service called recommendation service, but is written in Python, of course. And yeah, but also I don't think this is nothing new, and usually like logs are the first thing you use to troubleshoot issues. And also in OpenTelemetry we have also a way to, well, in the works, there is a way to use profiling data as telemetry data. That is like collecting stack tracing from a system and application. And this is done for like understand what our system are doing, and so which code consume layer sources like CPU, of course, RAM or memory. And so in OpenTelemetry, these four concepts are also called signals. Yeah, this is enough for the overview. Now let's look into Python-specific stuff. So the OpenTelemetry Python project it consists of two different repositories. The first one is called OpenTelemetry Python and contains a bunch of stuff. The most interesting things are the OpenTelemetry API package, where here we have what we call the OpenTelemetry API, but define only an interface that is exposed to users and is not tied to a specific implementation, because by default, our default implementation of the OpenTelemetry API is called OpenTelemetry SDK. And yeah, it's just an implementation of the API. And then another interesting package is called semantic conventions. And it contains all the attribute definition that are then populated by the various instrumentation we'll see later. The semantic convention define, in broad words, what data you get and how you get it. And the content of this package is generated automatically from a specification. And then we have the other repository that is OpenTelemetry, that is called OpenTelemetry Python contrib. Here we have all the instrumentation libraries. We have also the OpenTelemetry instrumentation package and the OpenTelemetry distro package. So each instrumentation library is packaged separately, so have their own package, Python package. Most of them are inside the instrumentation and directory, and all instrumentation are called OpenTelemetry instrumentation something. We also have some GenAI instrumentation that are on the instrumentation -GenAI directory. If you go on the PyPI package repository, you also see other packages named with this pattern, but unfortunately they are not distributed by us. Yeah. Again, we have also the OpenTelemetry instrumentation package that implements what we call auto-instrumentation or zero-code instrumentation. And this is the ability to instrument application without touching the application code. Then the OpenTelemetry distro package is a really small package that contains just some basic default configuration, like setting the default exporting protocols and stuff like that. Please note that the OpenTelemetry Python packages depend a lot on environment variables for configuration. And so the OpenTelemetry distro package is just a bunch of lines just setting environment variables. Okay, this was the whole introduction. Let's look at some of the tricks used to make our OpenTelemetry Python packages work. For this talk, I use just a very basic Flask application. that implement just an endpoint called hello world on the root that returns a string. So first, again, we're just going to set up a virtual environment, install, enable, activate it, and install the latest Flask. And to have the basic of OpenTelemetry packages, it is enough to install the OpenTelemetry package because it already depends on the API, SDK, and the OpenTelemetry instrumentation packages. So the first tool we'll take a look is OpenTelemetry-bootstrap. OpenTelemetry-bootstrap is a CLI tools that is from the OpenTelemetry instrumentation package that is able to list or install any instrumentation available for your project dependencies. So the first thing that it requires to work is an updated list of the available instrumentation libraries we have in OpenTelemetry and what library they can instrument. And this list with these matching values is built at each pull request. And so every time a new instrumentation library is added to OpenTelemetry Python, this list is updated. And so it is automated. So this file, this list of matching libraries looks like this. And again, it's just a map between what we can instrument, a library, and the instrumentation package that provides that instrumentation. So for this example, this is just an example, there are a lot more entries in this list. We have a match where we say if you find the Flask package installed with a version with higher or equal to 1.0, we have an instrumentation for that that is packaged inside the OpenTelemetry instrumentation Flask package. And the latest version of the package is 0.56 beta 0. And also on top of this, we also have some default instrumentation that are always installed on list. And this is because they don't depend on any third-party libraries. So for example, we have here the OpenTelemetry instrumentation async.io package and instrumentation that only depends on a standard library, so it will be always available. Now, let's try this OpenTelemetry bootstrap tool against the virtual environment we created some slides before. Here I'm calling the action parameter, the action install parameter, that will try to install the instrumentation libraries it finds for our dependencies. But here the output is just for the listing command because otherwise it will not fit inside the slide. So again, in this example, we have the default instrumentation. For example, we have the async.io instrumentation that will be installed or list. And then we also have our Flask instrumentation, and we also have the WISG instrumentation that is a common instrumentation that is a dependencies of the Flask instrumentation, and so it will be also installed. And this was the first command I want to show you. And now let's look at OpenTelemetry instrument, that is our way to implement auto-instrumentation. So OpenTelemetry instrument is a tool that is used to implement, again, auto-instrumentation, but is the ability to set up OpenTelemetry tracing, logging, metering, and hopefully profiling in the future for your part application without touching your application code. Just a quick question. How many of you already know about the sitecustomize module? Please raise your hands. Okay, not many. So hopefully you will learn something new. By default, in the standard library, there is the set module of your Python installation. We'll try to load from your Python path a module named sitecustomize. And OpenTelemetry Python auto-instrumentation use this trick and this module to actually being able to initialize yourself before your application initializes. So let's see a quick example to demonstrate how the sitecustomize module works. Yeah, simple print of the word. Nothing strange, I hope. And we just try to change our Python path and put it on the, adding the current directory. If you do the same command, the behavior changes. This is not magic. Well, may look like magic, also surprising, I guess. But the trick is that in the current path, we have a module named sitecustomize, so that the site module will load. And this module is just printing the hello part of our output there. And yeah, this is the trick. So OpenTelemetry instrument, now that is able to run itself before your application, will do a bunch of stuff. The first thing, it will load the distro. So it will load the default settings. Then it will load the configuration that usually provided by the distro. And then it will light the real thing that are the instrumentations that unless explicitly disabled, it will, and you can disable that only by an environment variable, if I remember correctly, all the instrumentation found are always enabled. And all of these things use the Python entry points in order to work. So this is an example of how you can use OpenTelemetry instrument. Here we are just exporting traces to the console, so we have a nice output on the console. As you can see, it works as a wrapper of the usual command you will start your application with. In this case, just Flask run because it's a demo. So an example of a trace, we won't go into details, but yeah, you can see that we are tracing like, of course, on a browser, I'm just calling an endpoint of this application. And so this is a trace generated by the Flask run server. And again, just to, we don't go into details again, but these attributes are the ones that are specified in the semantic convention I mentioned before. So, as an example, a comparison, if you will do this manually, this will be the amount of code that will be required to stop all the various stuff the OpenTelemetry SDK provides on top of our just 5 lines application. So, entry points, what are another thing that is working under the hood. Entry points are a mechanism that are used to provide discoverability on your code. This is the way the OpenTelemetry Python project implements plugins. So like everything is decoupled and pluggable thanks to the Python entry points. I'll show you an example from the OpenTelemetry distro package. In the PyProject TOML file, we'll just define what is called a group. In this case, it is OpenTelemetry_configurator. And then we'll define a name, in this case configurator, and a code reference. The code reference is just like a reference to some code. So in this case, it is the OpenTelemetry configurator, in this case a class, inside the OpenTelemetry distro module. And you can consume this data using, we have some helpers inside this import-lib metadata, but if you just need, like, if you use just one version of Python, you can use the import-lib.metadata standard library package module, or like us, we are leveraging the backported module that is called importlib_metadata. So in this example, we are just going through these entry points. We are consuming the OpenTelemetry configurator group that we defined before. And we're just getting the class name, that is the one we define as a value of the name value we set before. And we're just calling the configure method of an instance of the OpenTelemetry configurator. This is just an example, you can use them for everything. Okay, so last magic bit we are seeing today, that is monkey patching. So monkey patching is a technique that is used to dynamically change the behavior of some code at runtime. Like everyone said, you shouldn't use monkey patching, but unfortunately, this is what we have. And this is what is used by most of the instrumentation libraries that needs to wrap the other classes, methods, or functions. So imagine we want to trace a function, so we need to wrap it to get like maybe the function parameters and also what it returns. Some of the stuff we can instrument provides some hooks, so we don't need monkey patching, but most of them don't. And so this is what it is like. And yeah, thanks to monkey patching, we are able like to get the data we use like to create, again, traces, logs, and send metrics. And the secret sauce we use is just using the great wrapt library from Graham Darbenton. You maybe already use it for writing decorators, but is also used for monkey patching. And so, yeah, it's awesome. I left a link to documentation, but if you need something like that, just use wrapt. I provide a couple of examples. First one is from a demo from another talk I did some time ago. And yeah, we don't go much into details, but wrapt provides a wrapper function where we provide the model to patch, and in this case, the function to patch, and we just need to provide our own implementation. In this example, I've used this like not like common use of tracing, but I created this instrumentation to trace how many times a Django async application did go from async to sync and the other way around. And so when the asgref async to sync and asgref sync to async function were called, I just printed, I sent a trace with the a stack trace in it. This is like something you won't do, but it was a fun exercise. If any of you is a Django developers, maybe knows like but the async support is not complete yet. And then another example that is, this is from a real instrumentation that is wrapping a class providing a stream. This is from the Botocore instrumentation. Botocore is a wrapper for AWS APIs, that is the one used by Boto3. And so here we are substituting the wrapper that is returned by Botocore with this convert stream wrapper. Sorry, we are substituting the result stream that is returned by Botocore with our own convert stream wrapper. And this is used so we can process the data returned by this iter method. And so this is an iterator. And again, if you want like to have the data and keep the behavior the same, this is a nice trick. So here we are consuming the iterator. We are doing our own processing and just yielding again the stuff we read. So the consumer of this iterator won't see, but we are already consuming it. So time for conclusion, 1 minute left. Yeah, you've seen like a bunch of tricks we are using in OpenTelemetry Python project, and hopefully if you're using it, it removes some magic. And even better if you may leverage this thing also on your application. So what we've seen, Our OpenTelemetry Bootstrap is able to scan your dependencies and install the available instrumentation. How the site and sitecustomize modules are used to run code before your own. Also, we have seen our entry points can be used for component discovery or for creating plugins. And last, we've seen like how we can use wrapt for patch third-party code. So if you're interested in the OpenTelemetry Python project, we are, of course, always looking for help. I left here the OpenTelemetry project, our links to our repos. We have, I don't know for how long, a channel in the CNCF, Cloud Native Computing Foundation Slack. And we also do a weekly call on Thursday to speak with each other if we need to discuss some topics. Yeah, I left also my Mastodon handler and a link to where I usually upload the slides on SpeakerDeck. We have time, so thank you. I'll gladly take any question.
Thank you, Riccardo. If anybody has a question for Riccardo, please come to the microphone that is in the middle of the room. And while we're waiting for a question from the audience, I would ask you, for folks running OpenTelemetry in production who may end up running into issues with either storage or memory utilization being really high, do you have any tips on how to cut that?
Oh, that's a nice question. Yeah, sorry. So one thing you can use to reduce the data exported, maybe using sampling. So we have the concept of samplers that you can load. We have samplers that can act on parent-based decision and also on samplers that can apply like a rate. And so usually people concerned with storage and cloud costs usually use samplers because otherwise it will...
Makes sense. Thank you.
Sure.
First question there.
Yeah, hi. So I'm a big fan of OpenTelemetry because it sort of lets us escape these expensive SAS vendors. And so my question, maybe a warning to others, is have you already experienced issues with forking Python projects, forking Python software that uses OpenTelemetry? Because I hit this problem in my company with RQ, that you have SSL problems in this sort of forking situation because of state being reused in the child processes, and it's super hard to debug. So just warning to others, if you use OpenTelemetry with RQ, this is gonna hit you. And our workaround was to initialize it twice, once in a parent process and once in the child processes. And like, have you ever experienced this situation before yourself?
Yeah. Usually we have issues with pre-forking servers like Juniper. And yeah, the idea is that you should probably reinitialize the SDK on fork. So yeah, we can go into details maybe later. Because
yeah, but just saying to everyone that that is a problem. And
thank you very much.
Yeah.
Can I ask for the next question, please?
Hi, thanks for the talk. I just wanted to ask, if I'm building a library that wants to have OpenTelemetry support, I want to have native OpenTelemetry integration, and any pointers on what I should be doing?
Yeah, the idea is that you maybe add an optional dependencies on the OpenTelemetry API package, and then like you can use the API and create your own traces.
Yeah, so my question was, it's not recommended to have an external package for the instrumentation?
Well, it depends. Like for us, as an upstream maintainer, I would love to have the package itself maintains the integration.
Can you name an existing package that does this?
Yeah, the Elasticsearch client have their own OpenTelemetry instrumentation. So you can take a look at Elasticsearch client.
Thank you.
Thank you.
Thank you very much. If you have any other questions for Riccardo, he will be available on Discord, I believe, in the Terrace 2A room. Also in the corridors for a nice chat. Sure. Thank you again to Riccardo.
Thank you.